Hello and welcome to our physical sciences session. My name is Themba Ncube. Today we are focusing our attention on exploring, the kinetic molecular theory of matter to try and understand, what exactly happens at a very microscopic level and try to link that with what we exactly observe, when, a change of phase takes place within the three states of matter, which is the solid, liquid, gas. So we'll look at this actually, in terms of the physical properties of materials within the broader section of matter and materials. Right. Having said that, so we want to also appreciate that our focus is on the kinetic molecular theory, of matter, to try and explain, in terms of why, matter behaves in the manner it does under different, conditions, and why, solids, liquids, and gases, have got different properties altogether. So this relates actually to the physical properties of materials, right? Okay, so what's the thinking that's going to guide our discussion for today? The big question that we want to ask ourselves is that what evidence, because science is purely based on, empirical evidence. So we are saying what evidence is there for the idea that matter consists of particles? But this is, in the backdrop or, on the background, we understand that matter is anything that has got mass and it occupies space. So the big thinking that we have today is that what exactly suggests or what evidence is there for us to really say that indeed matter consists of what we would call, particles, right? Okay, so that's the big idea. Keywords in terms of the terminology. We also has to remind ourselves that, remember, the language in itself is located within the context of science. Now, so in physical sciences, our definitions, terminology is either we know or we don't, which is based on our remembering skills. So what is our point of reference for what is actually acceptable in terms of definitions will definitely be our examination guidelines. So what are the keywords that will, be used quite often in our discussion for today? The key terms are diffusion as well as Brownian motion. So Brownian motion is actually capital letter B. Why? Because it was named after, a scientist, so it's somebody's name. Hence, we'll call it the Brownian motion. Right. Okay. So what is diffusion? Diffusion is the spontaneous movement of particles from an area of high concentration, to an area of low concentration. So these particles are actually in constant state of motion, right? And then during diffusion, what happens? Particles move from a region where there's many of them to a region where there's very little of them. And then that suggests something, as we are going to discover, about the nature of matter in as far as the kinetic molecular theory, right? Okay, so practical examples of diffusion, because diffusion is about the movement of particles from a region of high concentration to a region of low concentration. What are some of the, everyday life examples? So if we add, let's say, for example, a food colorant in a beaker containing water, what is it that we would observe? We would observe that, the color will spread, gradually throughout the whole, so to give us a uniform color at the end of the day. So that's a practical, observation in as far as diffusion is concerned. What about the smell of air freshener? Filling up a room. So what you'd observe in real life, you get into a room, you stand by the door, you spray, let's say, an air freshener. After a couple of seconds, the person sitting right at the corner will observe the smell. So it says something about the movement of the particles. But our focus today is precisely to try and bring an understanding to say, at a microscopic level, or from a microscopic view, what is happening in terms of the particle. But remember the big question that we asked in terms of the evidence to say that matter indeed consists of particles. Right. So these are the practical examples in as far as diffusion. Right. Okay. Right. Now, what can you deduce about the matter, about the behavior of matter, that is, from the observation of diffusion? So this is the question. So science, in many ways, in its very nature, it's about us asking questions, and the questions that we pose actually, must be accompanied by a certain way of thinking, okay? So for us to arrive at a conclusion, there must be supporting evidence. It is the inquiry, nature of science. That's how science is all about. Hence, we always want to focus ourselves about asking a lot of questions. So it's not so much about the correctness of the answers that we give, but also the questions that guide our thinking in terms of understanding, the bolts and nuts in terms of the detail. But our focus today is precisely on, the behavior of matter. Why do we say that indeed matter consists of particles? So we'll keep on, reminding ourselves of the big question as we try and discover some of the very exciting facts about the nature of any form of matter that is, right? Okay. And then, so the practical examples of diffusion, we know that matter must consist of very small particles, okay? Particles can be molecules, atoms, but the word particle is used generally to refer to those units that make up a substance, okay? Now, and secondly, there must be spaces between different particles, okay? For particles to actually move from a region of higher concentration to a region of lower concentration, we are saying that there must be spaces through which these small particles, these minute particles, actually move, okay? Otherwise, the movement or change of position of particles making up a substance will not be possible, okay? So it means there must be spaces, right? We're onto something here. And then it says here, the particles of matter must be moving into these spaces. So there must be motion, okay? Now, already, what do we know? We know that any form of nature, any form of matter actually is in a constant state of movement, okay? So movement, motion, we're saying the same thing, right? Okay? Now, and also these particles have got kinetic energy. Now, the word kinetic energy, very, very important, because it has to do with the energy that the particles have, by virtue of them being in a state of movement or in a state of motion. So a particle that has got greater kinetic energy is moving faster, okay? So that's the link. Those, by comparison, that have got very low kinetic energy, the speed is very slow. But, we are saying that all forms of matter are in constant state of motion. So there is some kinetic energy, be it a solid, be it a liquid, be it a gas, right? Okay. Otherwise, diffusion will not be possible. Now let's look at a practical demonstration of what exactly happens, because some of these ideas can be somewhat abstract, but if we actually get to see and we try and, at least derive some understanding in terms of what exactly happens, okay? So let's look at, for argument's sake, this simulation that shows what exactly happens when diffusion occurs, okay? Right, so these are the particles of a substance, okay? So if these particles are in a state of motion, you'd realize that further to our left, there is a high concentration of particles, okay? Now, these particles, they move across the barrier to a region where they were low concentrated. But one also has to appreciate the fact that, generally, any form of matter has got particles that are in constant state of motion. Okay, so the observation with the food colorant spreading through the water solution, water as a medium, actually, it says that between water molecules, these particles can actually move from one point to another. Okay, and for that to happen, it means the particles themselves of the colorant must be in a state of motion. Right. Having said that, let's go back and try to understand this in context. Okay. But furthermore, we are saying there is more evidence to suggest the particle nature of matter. So when we talk about the particle nature of matter, we are saying what evidence is there for us to really say, indeed, matter consists of particles, okay? Now, this takes us to the next stage, of our discussion, which has to do with the Brownian motion. Okay, so Brownian motion is actually a phenomena or an observation that was made by one of the earlier scientists, which is Robert Brown. You can read more on that to try and understand in terms of the timeline how this idea developed, okay? But what exactly does the Brownian motion entail? According to Brown, or the scientist concerned, the motion of pollen was observed in water. So pollen are these, grains from flowers. So if they were actually put in water, you'd actually realize, because they are colored, you can realize that they actually move through water molecules. So under a microscope, of course, because this is quite microscopic, so the movement could be seen through the water molecules, which suggested that there are some spaces between water molecules, okay? Which suggested that there were some spaces between water molecules, okay? So this is the particle nature of water. And also to say that the water molecules are in a state of motion, okay? So the water molecules are in a state of motion. So this is very important in terms of properties of matter, okay? So they're in a constant state of motion, okay? So a similar observation can be made with when you mix these two substances, okay? If you have, let's say, a glass full of water and then you add some milk, you'd realize the movement of the milk particles through the water. So what does that suggest? It says to us that there are spaces, and again, the water molecules are in a state of what? Of motion. This is something that would collect as evidence in terms of trying to understand, the particle nature of matter with respect to the kinetic molecular theory. Also, if you observe smoke that is, emitted, let's say from a chimney, the movement of the particles of smoke suggests that within the air there is some spaces, and that the air particles are, in their own right, are in a state of motion. Right. Okay. So the Brownian motion pointed out very important things about the nature of matter, that there are vibrations, which is actually movement of particles, right? Okay. So the vibrations are actually the movement of particles, and then there's this jerky motion that you'd also observe as far as, let's say, smoke as a practical example, something that is, an everyday observation. And then there's also a random change in the direction of movement of particles. So the random changes in direction suggest that there is no order in terms of the direction in which the particles are actually moving. Right. Now, in terms of the kinetic molecular theory, which is the main idea for today, we're saying that this kinetic theory of matter is just a model that explains the behavior of particle, nature of matter. So we want to understand, the nature of matter with respect to the kinetic molecular theory. Remember, the word kinetic suggests something about movement, okay, of molecules. Okay, so this theory is actually a model, just to break it down in terms of what it's all about. So the kinetic molecular theory of matter suggests that all matter consists of particles, right? As we have seen from, diffusion, okay, as well as the Brownian motion, okay? So these phenomena, they actually provide evidence in terms of the particle nature of matter. And again, we're also saying that particles of matter are in constant motion. Okay, remember, kinetic suggests something about the movement. So it means any form of matter consists of particles that are in a constant state of motion. And furthermore, there are empty spaces between the particles. Okay, very, very important. Otherwise, the diffusion as a process wouldn't have been, possible if there were no spaces. But remember, for these particles to move from a region of high concentration to a region of low concentration, there must be spaces. And while there are spaces, these particles in their own right, they must be in a state of motion. Okay, so I think that's how we link the two together. Okay, and then again, the forces that exist between the particles, either attraction or repulsion, as the ones that allow us to have a certain form of matter, taking the shape of the container or having a definite shape. It means there is something or forces that actually keep these particles together. Right. Okay. And when it comes to the random movement, there will definitely be collisions between the particles, okay, and the walls of the container. So according to the kinetic molecular theory, these collisions, they don't result in any loss of energy or energy transfer. Why are we saying transfer as opposed to loss? Okay, remember, we know that energy cannot be created or destroyed. In other words, we want to carefully use the word lost energy, okay? Because energy is actually converted from one form to another. So the kinetic molecular theory, what it essentially tells us is that the collision of these particles, because we're saying that this movement is quite random, then if there are collisions between the particles themselves or between the particles and the container walls, these collisions are actually do not result in loss of energy, and we say those collisions are actually inelastic. Okay, and then furthermore, we are saying particles do not possess the same amount of energy. Okay, the amount of energy is not the same. Hence, we talk about the average kinetic energy, which is related to the temperature, right? Which is a very, very important point that we'll try and explore even further. Right. Having said that, so we've managed to look at, how diffusion provide evidence relating to the kinetic molecular theory in terms of the fact that, all matter consists of particles, and these particles that make up matter are actually in a constant state of motion. So after the short break, we'll try and explore the kinetic molecular theory more into detail. Let's take a short break for now.